Okay, this is number 35 on section 3.4. And basically we're talking about this lava shooting out of this volcano in Hawaii in 1959. So it began with a line of fountains, etc. But what happens is the activity was later confined to a single vent at the crater's floor, which at one point shot lava 1,900 feet straight into the air, a world record. What was the lava's exit velocity in feet per second? So how fast was it leaving in feet per second? And they give you a hint here. They tell you that if v sub 0 is the exit velocity of the particle, its height t seconds later will be given by this position function. So if we have a particle that shoots out of the volcano, its height after t seconds is given by this expression. And what we want to do is we want to find out the exit velocity in feet per second, how fast it was going, which would be v sub 0. So we want to find out about v sub 0. Now we know what happens when it hits the maximum height. When it hits the maximum height, it stops. So we can take the derivative and find the velocity function, which is just the derivative of the position function, which was given to us. So the derivative of this position function will be v sub 0 minus 32t. And we set that equal to 0, because that's going to be the maximum height. And we know that that's maximum height, well, the position of the maximum height will actually be 1900. So we could solve this for v sub 0 in terms of t, or t in terms of v sub 0. So this will be the time when my velocity is 0, v sub 0 over 32. So I can put that time in the position function, and I know that that's where I'm going to have my maximum height. In other words, I'm going to go up and up and up, and I'm going to stop at the maximum height, and I'm going to come back down. And I know that at maximum height will be actually 1900. So I set this position function, and I'm going to set that equal to 1900. And that's going to give me my maximum. That's going to be at the maximum height. So that equals 1900 when t equals v sub 0 over 32. So s of v sub 0 over 32 will equal 1900. Okay? So this is my time when I'm at my maximum height that I found out over here, because that's when the velocity was 0. So I substitute that v sub 0 over 32 into the position function. And remember, this is going to be equal to 1900 at the maximum height. Okay? So we can simplify this a little bit on the left. V sub 0 over 32 minus 16 v sub 0 over 32 squared. Then if I multiply that, I get v squared over 32 minus 16 v squared over 32 over times 32, as I square that. 16 goes into one of those 32, so I end up with v sub 0. Now remember, this is all equal to 1900 over 32 minus v sub 0 over 64. And that's two of those over 64, so it ends up with v sub 0 over 64, and that's equal to the 1900. Okay. And if I multiply both sides by 64 and then take the square root, I have v sub 0 equals the square root of 1900 times 64. That's a times, not point. And that ends up being plus or minus 348.712, and that's going to be feet per second. Now if I want to find that in miles per hour, I've got to get rid of the second, so I have 3,600 seconds in 1 hour. And I want to get feet to miles, so I've got 1 mile is 5,280 feet, and I want to do that so the feet will cancel, the seconds will cancel, and I have miles per hour. And then when I multiply this number, 348.712 times 3,600 divided by 5,280, we get 237 miles per hour, so that's the exit velocity. Okay, so I hope that makes sense.